You are not going to be a popular person if you're not careful.
Yeah, that sounds good.
All right, guys. I was trying to decide what to do this morning, what was more important, because we're a little bit behind the schedule. And I think what I want to do is 11.2 and 11.3 are both interest problems, right? 11.2 is simple interest. Have you guys ever seen the formula?
Yes.
Yeah.
No.
What's the
Percent rate time.
Right?
Percent rate time.
So I be pretty. Interest equals principal times rate times time.
Yeah.
So hopefully you guys, you either have an account where you're getting some percentage return maybe, or you don't, or you have some loans where you're paying a percentage to somebody else. Somebody else is making a percentage off of you, right? So you got like a car loan or student loan or something. Or if you have none of that, well, you will eventually. Right? So how do they determine if it's a 5% account that you put your money in? How do they determine how much money you get at the end of the year? They could use a simple interest formula, right? So if you put $400 into an account making 5%, which is 0.05, for 1 year, how much interest have you made? 400 times 0.05. So you have to know how a basic account works, right? And really all section 11.2 does is we use that formula, and they sometimes tell me this and this and this, or they sometimes tell me this and this and this, and I have to solve for t. You know, so I'm going to make that section extra credit. So if you want to do that, it's extra credit. Is it 11.2? That's what we have so far.
3.6 is still extra credit.
Yes.
3.6.
So what do we have so far for extra credit? 3.6, 11.2.
That's it.
There's a very hopeful comma up there. 11.3. Has anybody heard of compound interest?
Yeah.
Like amortization or?
Something like that, yeah. We're not going to get that deep into it, right? Because the part of this section is all about mortgages, and you can even get deeper into it in points. But compound interest is, simple interest is you just apply the percentage when you take the money out. So 2 years later, you first apply the percentage when you go to take the money out. Compound interest is, what if I want to apply the interest every month? So then I'm making money, the money goes into my account, which makes more money, which goes into my account, which makes more money, which goes into my account, which of course is better, right? Your money's making money. It's always nice. That's what 11.3 is all about. I'm going to make that extra credit too. If you have the money in the first place, yes. But like the old adage says, it takes money to make money. Yeah.
Is extra credit due before the next test? Or?
Extra credit is just do it by the day of the final exam.
Oh, okay.
Yeah. So you got time on extra credit. I'd much rather you keep up with what's not extra credit, what's just needed. So do that when you have time if you want to. Okay. So what I want to get into is chapter 9, and I'm really trying to keep like chapter 4 in the right place, because chapter 4 is where our big project is going to come from.
Great.
Where we're going to start working in groups and start working on interesting stuff. So I got to give us enough time for the semester to do that.
Yeah.
Right?
So what section is that?
4 is eventually where we're going to get our big project from.
I can't wait for chapter 5.
So we're doing 9 right now.
What's up?
I can't wait for chapter 5.
Okay. You like Fibonacci?
Yes.
Fibonacci kicks ass.
All right.
I loved it when I found that video. It was amazing.
Oh yeah, did you send me the? Yeah. Okay. So Fibonacci is coming up. He's in our future.
You should
And
definitely show that video to the class.
Fibonacci is silly. You could spend an entire lifetime studying. Thankfully, we're not going to do that. But you could. What we're going to get into today is something that might seem kind of boring, but I'm going to show you a few things you might have never seen before related to this. Chapter 9.
Oh, then this is chapter 9 right now?
Yes.
We're doing?
Oh, yes.
Okay.
All right. So is everybody with me on this? 3.6 I made extra credit a while back. 11.2, 11.3 is now extra credit. So you don't have to do it if you don't want to. We're going to get into chapter 9 now. And I know there's at least one thing in here. Be careful now. Some people are staring daggers at you. Some people hate geometry. Now, guys, class. So you guys are like, I'm not a guy. People. What we're going to focus on with geometry is just area, perimeter, and volume forms. We're not going to talk about parallel lines or transversals or alternate interior angles or side angle side proofs. Any of this sound familiar? That's the most I'm going to mention those. Alright, so let go of that. Wow, you guys are rambunctious. The basics of geometry, there's one thing I'm going to show you that you probably never seen before. It's one of my most favorite little things, and someday I might actually bring in construction paper. I'm just normally not that kind of person, but you can do something really interesting with construction paper that'll show you something. But anyway, we're going to start off with area and perimeter. Now, perimeter, the funny thing with perimeter is you do not need any formulas for perimeter. You probably know one of them already, which sort of sucks, actually. It kind of makes you guys mess up a lot in algebra. Does anybody know a perimeter formula right now? It's the most basic one, really. No, it's volume.
2L plus
That sounds more like volume.
1/2.
Was it 2L plus together?
Yeah. So what's the perimeter of this?
2L plus.
Now, where does that really come from? Because what does perimeter mean? If you're going to walk around the perimeter or something, you're going to walk around it, right? It has nothing to do with the inside. I don't care what's going on inside. It could be filled with water or jello. I don't care. I'm going to walk around the room, right? Walk around the edges. So it's all about, here's an L plus a W plus another L plus another W. So there's 2 L's and 2 W's. That's not a formula I have to memorize, right? What's the formula for this shape? What's the perimeter of that? Well, if I tell you all the side lengths,
Yeah, plus 7.
right? If I tell you what all the lengths are here,
Yeah.
do I need a formula?
No.
And these are all, let's say, feet, blah, blah, blah. Thank God, because how many shapes could I make like that? Infinitely many. So thank God there's not a perimeter formula I need for everything. It's just an idea. Add up all the sides. Ooh, right? You guys with me?
Yeah.
So what sucks though, I don't know if you guys remember in algebra when you have these problems, I want to make a garden, I want to put a fence around it, and I got 40 feet of fencing, and I want it to be twice as long, you know. Like, why do you want that? Just go with it. What everybody always does is they only go halfway. So you're trying to keep the little bunny rabbits or whatever else, and then you're going to build your fence like that, and here they come. Yay, yummy. Right, so everybody always goes halfway. They say x plus 2x. Oh, you haven't gone all the way around yet, have you? So just remember, perimeter is just going all the way around something. I don't care what the shape is, just go all the way around it. The only real formula we need is the one shape that we look at that doesn't have straight sides.
A circle.
Circle. Right? Because with a circle, if I'm not allowed to sit down and just put a string around it and then see how long the string is, right? That's one way to get that. I need some other way. I can't add up sides because there really is sort of like one side that's curved. Well, shit. So here's, what's that called? So that's the diameter, and the radius is just half that.
And then the circumference.
So here's the funny thing. What somebody found out was, I don't care how small or how large, if you cut the earth in half, there's a circle there, basically. Right? It's not quite circular, but let's go with it. Right? I don't care how small or big the circle you're looking at is. Here's the funky thing people have discovered from way back when. If you take a string and you put it around the base of a trash can or something, right? And you see how the diameter of the trash can. And then you see how long the string is, which would be the circumference, wouldn't it? Right? So if I take the circumference of any circle ever existed or ever will exist, divided by its diameter, it always comes out to be the same number, which is why it got a symbol. Pi. So they kept getting the same stupid number, and people in Egypt and people in Greece and all, they were all freaking out. They're like, holy shit. No matter how big, I don't know what the word was for shit, but no matter how big, shit, I don't know. No matter how big or small, that'll be the room. how big or small the circle is, that ratio always came out to be exactly the same number. And throughout time, throughout history, there were some approximations for this. There was 22 sevens, which if you do 22 divided by 7, it gets pretty close, right? There are some other approximations, and of course nowadays we have computers that can calculate it out to the trillionth place, right? So that's where pi comes from. Anybody know that? That's where pi came from? Did you guys, some of you guys knew that? So it's really good when you're first teaching students about pi. It's a really good exercise to do. Just have a string, tie it around something, cut it off, diameter, and then lay it out and then divide. And you're always going to get something. You're not going to get perfect because they're not perfect. But if you average them all up, it's got to be pretty damn close to pi.
Can you also cut up the circle into parts and?
Oh wait, you're getting ahead of me. So you've seen that.
Yeah.
Don't steal my thunder on that. That's my favorite. That's the area though. That's coming up.
Okay.
Yeah. Stay with me. You doing all right?
Yeah.
All right. So here we got our first little formula for circumference. I just multiply the d up, pi d. But the one that I heard you guys saying, what is d again? What's the diameter? It's careful. It's the radius is half the diameter, so the diameter is twice the radius. So I get 2 pi r. That's the one you guys know, right? But either one of those works, of course. So finding the circumference. So the perimeter of a circle, we just call it the circumference. It gets its own name because it's its own freaky situation, right? It's special, exactly.
Just like
So 2 times pi r is
Yes.
the same thing as pi times diameter.
Exactly, because twice the radius is the diameter, right? So if I gave you, for example, a circle whose diameter was 11 meters, can somebody tell me, is circumference correct out to the 1,000th place? And in fact, what I'm talking about is, you guys have your calculators with you? Take them out. If you don't have it, then obviously don't take it out. That would be weird.
34.5.
Do you know where your pi button is?
3.14152654.
I love it. Is pi equal to 3.14?
No.
No, hell no.
That's all.
So unless the book says otherwise, I'll never say otherwise, but unless the book says otherwise, you use your pi button. That's why it's important to know where it is. Now, if you have a little times, minus, plus, divided by calculator, beep, or sometimes they're this big with monster buttons. If you've got that, you're not going to have a pi button more than likely, right?
Yeah.
Okay.
It's the scientific.
I'll tell you this, I'm a little, this is like tangent day for me, but going off on tangents. There was this cool, anybody have like a smartphone, like a Droid or an iPhone or something? Yeah. There was an application on there called Andy83 on the market. It was a TI emulator that was free, so you saved basically $100 and some odd.
The iPod's
It's not on there right now. They've taken it off the market because of a licensing issue, of course, with TI. I managed to download it for myself in time, so I've got it on my little phone. I'm not sure what's going to happen with it. It might go back up there, or it might not go back up
The
there. but-
iTouch has it though. If you flip your iPod, it'll it has a full scientific calculator.
Yeah, when I
Well, full scientific, but not graphic.
when I turn
No.
on
Oh, okay.
Somebody has.
But you can. There's all kinds of calculators you can download if you have the money for the smartphone. If you got the smartphone, but you're worried about your calculator, just download a damn app. They're free. Really decent free apps for calculators.
Bet you won't be free.
The problem is you can't use them on a test. Your phone.
Oh.
Well, if we shut the phone off and who's got the
Well, I can't keep tabs on that. I'm not going to keep records of who's got the phone out and who's shut it off. I'm not going to do that, sorry. So, figure out where your pi button is. If you don't have a pi button, 3.14 gets you close, but it actually gets pretty far off pretty quickly. So C equals pi times, which formula am I going to use?
pi times d.
Yeah, because I know D. I could cut that in half, but why do that to myself? So C equals pi times 11.
34.557519.
34 point,
557519.
so 558. Because I said out to the 1,000th place, right?
Yep.
34.558 meters. That would be the circumference of that circle. How's that? Not too bad. Just maybe there's a crop circle somewhere. Mel Gibson's out there in this field. Yeah. At least one person got that right. All right. So really, that's the only perimeter formula we need.